My name is Adilet Zhakeyev. I'm a research associate at Harvard University. Today's talk is about multi-material stereolithography by cross-linking through luminescence excitation. Photopolymer-based 3D printing techniques such as stereolithography, digital light processing, or LCD 3D printing, UV or blue light are commonly used, which have short penetration depth. Our approach utilizes near-infrared to UV visible light of conversion emissions from phosphors to initiate photopolymerization at a much higher depth. This concept relies on use of invisibility windows and nonlinear optical effects to achieve selective cross-linking in photopolymers. The near-infrared light penetrates into the bulk of the resin to a desired depth, where the optical conversion into UV to visible light happens, initiating photopolymerization. In order to improve the resolution of this technique, we have added the photo-absorbent dye into the formulation, which allowed us to reduce the cure depth and cure width. By introducing a low-cost 980 nanometer laser dye and repurposing an FDM 3D printer, we were able to 3D print using this method. For example, a single material structure shown here. The high penetration depth offered by near-infrared light excitation also allowed us to print through and inside already 3D printed structures, and addition of other colored dyes allows also for multicolor 3D printing too. And this technique was also demonstrated to be useful in 3D printing with different types of polymers, for example, flexible and rigid polymers. The introduction of silver salt into the resin formulation can provide the catalytic sites for metallization via electroless copper plating, and it can be used for selective metallization using the common photopolymer-based 3D printing techniques such as LCD printing, digital light processing, stereolithography, or it can also be applied to the near-infrared assisted 3D printing method as well. Thank you for listening. If you would like to discuss this further, you can contact us on the following emails. And finally, I would like to thank EPSRC for supporting